Dobry dzień. Good day, folks. I'm Peter Varhol, and I'm work now as a consultant, and my goal, as you probably heard at the beginning, is to enable enterprises to treat their data as they do their application development processes, their DevOps processes, so it's integrated into both technical and business operations. My talk is Correlation Does Not Mean Causation, Testing Insights into DataOps, Big Data Analytics, and Artificial Intelligence. A little bit about me. I'm an international speaker and writer. Last year was the first time in 10 years that I did not make a trip to a conference in Europe, to my everlasting regret. But last year was, I'll say, a challenge for all of us. I have graduate degrees in applied mathematics, computer science, and oddly enough, psychology. At this stage in my life, because I've been an academic, I've been a technology journalist, I've worked extensively in various technology industries, I consider myself to be a technology communicator. I love diving deeply into new technologies, getting excited about them, and explaining them to people. I have 4 different AWS certifications. I am a former university professor and technology journalist. I am also a cat owner, and you see their photo there, and also a distance runner. I am just concluding in that photo, I'm just concluding my first half marathon in Reykjavik, Iceland. And should you wish to ask me questions or communicate to me in any way, my email is peter@petervarhol.com. So here's what I'm hoping that we can talk about today. How AI systems will make determinations they do based on data, why big data is so important in analytics and AI, and what we're actually learning when we work with big data, data operations in artificial intelligence and analytics systems. So I'm going to talk a little bit about the evolution of data, the role of DataOps, the logistics of big data, using data to train machine learning systems, what it means that your data might be biased and it might not be telling you what you think it is. And then I'll summarize and offer some conclusions. So in talking about the evolution of data, as I said, when I first got into computing, and I'm a more mature technology person, so I was actually a babe in the industry about 30 years ago. Hardware was king. Your basic 8086 PC with a whole 640K of memory cost $5,000 and up. So we focused on trying to make things that made sense to run on that sort of hardware. 20 years ago, or back, I'm going to say in the late 80s into the 90s, software became more important. As hardware got less expensive and more powerful, we were able to write more useful software. And that added a big boost to how we view data and how we process data. 10 years ago, hardware and software went into the cloud. We all of a sudden did not have to make a significant upfront investment into hardware and software. We just took what we had and we moved it in the cloud, and we paid by the processor cycle, we paid by the month, however we paid for, but it was no longer a capital investment, it was an ongoing expense. Today, however, nothing really matters but the data. Let's talk a little bit about that. As I said, prices fell with commodity hardware, and storage became much less expensive. We also developed better software abstractions. There were, I will say, when I was a technology journalist and I ran various types of performance and other tests on various computers and operating systems in the 1990s, there were probably 6 or 8 or even 10 operating systems that we had to focus on, various versions of Unix, a couple of different versions of Windows. Linux was starting to emerge at that time. And then there were the proprietary operating systems such as VAX VMS that we had to worry about too. So operating systems became standardized. So my next bullet here, when I talk about Nicholas Carr being wrong, software did matter. Nicholas Carr is a technology journalist who wrote a article for the Harvard Business Review about 15 years ago, and also followed up with a book on the topic called Software Doesn't Matter. And his whole thesis was that everybody is using the same packaged software. Everybody is using SAP, everybody is using Oracle Financials, everybody is using Salesforce. So it really, software was not a competitive advantage. Now we see that, of course, software is very much so a competitive advantage. And at the same time, business decision makers became comfortable with data. I used to teach in an MBA program. I taught operations research and I taught business statistics. And I can't tell you how many times I heard from my students, I don't need any of this. I just make decisions based on my gut feel, based on how I think, based on how my experience says this decision should be made. Gut feel is no longer an acceptable basis for decision making. If a business executive comes up to you and says, I made this decision based on what I feel in my gut, you would probably discount the decision almost immediately. Storage is also cheap. We can easily store and retrieve terabytes of data. Processing is fast and continues to get faster through multi-core, multi-processor systems, through faster cores, through faster processes, through more complex routing algorithms that enable us to break problems apart into constituent parts and then put the solution back together again at the end. And data can produce information. Our decision making is becoming more refined. So what does all this mean? The business is now making use of data in ways that they didn't 10 or 15 or 20 years ago. The data that we're collecting and that they're deciding on is often in real time. The days of running monthly reports to see what has happened in the past, what were our sales in the past month, what was our delivery time in the past month and things like that, are increasingly irrelevant. Instead, we want data, we want information on what is happening on our business processes today. Data is also critical to machine learning applications. And I'm going to talk a bit about machine learning applications, artificial intelligence, a little bit later in the presentation. At the same time, IT has to keep the data up to date and clean. The fact that if you've got data sitting in an S3 bucket somewhere that is not being cleansed, is not being utilized, it's essentially wasted. Old data is worse than useless because it might be misleading. So what we need, and this is the whole idea behind DataOps, and I've got the next couple of slides on DataOps. We need a data pipeline similar to the development, test, delivery pipeline we have with DevOps, where data is able to become information in an automated way and seamlessly. So with that in mind, what is DataOps? DataOps means that our data collection processes become a natural part of business operations. We shouldn't have to say, okay, I'm going to take this data that I have and I'm going to put it into a database and I'm going to start doing things with it. Instead, DataOps means no out-of-cycle effort is required. The whole thing from gathering the data, to cleansing the data, to standardizing the data, to moving it into a storage system, to processing the data and making information out of it and giving it to our business decision makers is all one automated process. And it's not only automated, but it's a consistent, repeatable process. So let's compare in a little bit more detail DataOps to DevOps. Data can be designed to follow the same types of flow as DevOps. We define a process and we go ahead and automate that process any way that we can. And we're also going to find that with regards to DataOps and processing data, that just about everything in that process can be automated in some way, shape, or form. Data production and workflow is important to effective data consumption. If somebody wants to know what happened with their business process, what happened with sales, 2 hours ago, we should be able to provide them with that information. Also, just like in DevOps, DataOps consists of a cross-functional team where we have developers, testers, SREs, release engineers, ops people within the DevOps process. We have people like DBAs and report writers in a DataOps process. So why would we want to do this? As I pointed out, many enterprises, I'm going to say probably just about all enterprises, are collecting, storing, managing data in exactly the same way they did 10 or 15 years ago. Yet they're collecting 100 times, factor of 100, I'll say, more data today than they did 10 or 15 years ago. And so they're not understanding how best to handle that data. To them, it's just, we're doing the same old thing. It's just more data. No, you shouldn't be doing the same old thing, because since you have more data, oftentimes streaming data. I was talking to somebody yesterday about streaming data and about how important it is to data such as maybe coming from sensors on an autonomous vehicle, sensors on or instruments on a manufacturing process, or even things such as data coming in from aircraft and things like that. All of this is time series streaming data, and we need to be able to process that and make decisions on that in real time. And specifically, enterprises cannot wait for the next monthly report on how their business processes are working. So what I'm trying to do is I'm trying to help companies better understand their data and better understand their data processes so that they can build better data processes, because data is now more than any other thing that we are doing in computing. Data is now very much front and center. So this is from, as you see with the last bullet here, this is from the DataOps Manifesto at www.dataopsmanifesto.org. But it's modeled, of course, after the DevOps and further back the Agile principles. Individuals' interactions over processes and tools. We want people talking to one another. And I actually have a separate presentation called "Talking to People: The Forgotten DevOps Tool" that maybe in the future I can give to this audience. But people and how they interact with one another and the information they exchange is more valued over the processes, the specific processes we define, and the tools that we use. Working analytics over comprehensive documentation. Once again, working code, running code over documenting that, very similar to Agile and DevOps principles. Customer collaboration over contract negotiation. What really do you need to make better decisions? I'm talking not only external customers, but I'm talking internal customers too. As you go to your data consumers, your decision makers, and say, what types of information do you need in order to make better decisions? Experimentation, iteration, and feedback. Once again, iteration over extensive upfront design. I don't know of too many people who do extensive upfront design these days, but that used to be, I'll say in the 1980s and 1990s, by far the most common way, the most accepted way of designing software. What we want to do is we want to experiment with different ways of processing and presenting information. And last, cross-functional ownership of operations over siloed responsibilities. You're like the DevOps teams where you don't necessarily, and the Agile teams where you don't necessarily say, I'm a developer, I'm in the development group, I'm in the testing group, I'm in the release group, I'm in the operations group. You say, I'm on a DataOps team. So we need this because data is increasingly a valuable commodity, and it's going to get much more valuable over the next decade or so. And we need to reap business intelligence, technical intelligence, business intelligence from that data in real time, and it's got to be a standard repeatable process. And we have to get that information into the hands of the data consumer for analyzing our business processes, our business environment, what's going on, not last month, not last year, but in real time, and for decision-making, immediate decision-making into the future. So we need DataOps for auditability. We need to be able to version our inputs and outputs so that we know which model created, processed our data into the information we need, and where, in fact, it was implemented. We need reliability. We need to be able to get that information into the hands of decision makers, data consumers, information consumers quickly, but with better consistency and better quality. Repeatability, we automate not because automation is necessarily the be-all and the end-all, but we want a repeatable process. So we know that automation has a tendency to fail when our process is no longer repeatable. So, but if things are going well, automating that process makes it a snap to be able to process and deliver the same data today that we did 6 months ago, or I should say the same information today as we did 6 months ago. And productivity. We want that self-service environment. We want the data consumer to be able to decide what information they want and how best to access that, that information in order to make their decisions. And as I said, it is a team sport. This is not, we are not siloed here, just like we're not siloed in DevOps teams. So we might have a DBA, a report writer, a data scientist, data analyst, an operations person, a tester, a release engineer, and more as a part of that team. So one of the reasons we're doing this is we're no longer collecting one piece of data and storing it separately in a SQL database. Instead, we get data from a variety of sources. So we may be looking at, for example, our sales, but we may want to correlate that against day of the week. We may want to correlate that against, depending on what we're selling, we may want to correlate that against time of year. maybe outside temperature if our process or our data is something temperature dependent, or our cells might be temperature dependent. And we want to be able to seamlessly combine data from a variety of sources in our database, not store each of these items separately as we would in a SQL database. So we're measuring complex processes too, so we're collecting a lot of information on the processes. And as I said, we may be looking at weather, we may be looking at time of year, we may be looking at time of day. So we also need to incorporate data from natural and social sciences. And each cannot be their own separate database. We've got to find some way of combining them together to be able to turn it into actionable information. As I'm saying, a single source of data is no longer enough, and it can't be done manually. This has to be automated. I won't discount the fact that you might be able to do it in a SQL database, but I will say that NoSQL and alternative type databases may be most appropriate to be able to do this type of these types of operations in. So how about big data and machine learning? Our intelligence systems learn through data. We're increasingly building intelligence in our applications, and they learn through the data that we collect. Algorithms within those machine learning applications, I should say, oftentimes they're neural network based, which means that we've got a bunch of nodes in layers, and each of those nodes has a algorithm in it, anywhere from a simple to a complex algorithm. Those algorithms manipulate the data to reach a result. And it may seem like intelligence because oftentimes that's how we as decision makers make decisions too. Here, however, unlike what Nicholas Carr said 15 years ago, our algorithms are in fact our competitive advantage, not necessarily the rest of the application code, but our algorithms become our competitive advantage. And the better our data is, the more effective our algorithms are. So we use data to train our machine learning systems. What we do is we feed, those algorithms have the ability to adjust to reach to refine their conclusions, I guess I should say. So we feed in data with known results. We look at the results produced by those layers of algorithms, and we say, does this accurately represent what we know is the truth, or is further refinement necessary? So we feed that data through a series of non-linear algorithms that can adjust the parameters to be able to refine our results. We also tend to believe that once we deploy a system, that it's infallible. In fact, data is only as good as how we select it and how we collect it. It's usually a sample or representation of a real-world circumstance, a problem domain, call it. It's not necessarily exact, and it's not necessarily correct. And we may actually be using the data in the wrong way. It might not mean what we think it means. Worst of all, our data can be, in fact, biased. We're going to spend the next couple of slides talking about bias in data. And when I say bias, that data may not accurately and consistently represent the problem domain we're trying to develop our application for. I hate to say this, but all data is biased in some way. And we need to understand that bias. So where does bias come from? First of all, I'd say the most common area of bias is data selection. We choose data that represents only one segment of the domain or overrepresents one particular segment of the domain. An example of this is several years ago, Amazon wrote a bot to traverse the internet and look at credentials of people who might potentially work for Amazon, because they're hiring thousands, tens of thousands of people a year. So they look at, they wrote an automated system to be able to go and seek out candidates. Well, they trained this system through the resumes that they had received over the last 10 years. This did not work in their IT function. The reason this didn't work in their IT function is that they hired predominantly, I'll say almost entirely, male employees. And so what the algorithm, what the bot actually learned was that males made superior IT professionals than females. And in fact, it got so convoluted that they couldn't actually fix this and stop using that particular bot. Latent bias, concepts become incorrectly correlated. And if you look at this cartoon, you'll see what I'm getting at here. We've got two guys, one of which is doing some math on the whiteboard, and the other says, "Wow, you suck at math." So the second frame there, we've got, I will say, an overgeneralization in that a guy and a woman are there. The woman's writing the algorithms, and the guy comments, "Well, girls suck at math." So that's an overgeneralization in all likelihood. We could be promoting stereotypes. Interaction bias. I don't know if any of you have heard of Microsoft Tay. Tay was a Twitter bot that Microsoft had released onto Twitter, and it learned from its interaction with other people. Well, people learned very quickly that they could teach Tay anything that they wanted to. So after about 24 hours, Tay got to the point where it was misogynistic, it was sexist, it was cursing, it was racist, and Microsoft had to pull it entirely just because people were training it in an inappropriate way. So why does bias matter? We could be getting wrong answers, and oftentimes we don't have any recourse because we don't know how the answer occurred. And oh, by the way, I've just finished a presentation that I'm shopping around called Why We Need Explainable AI. If we develop our machine learning and AI systems such that they can explain how they get the result, oftentimes we might have recourse. We might have subtle discrimination, and nobody really knows that it's happening. We're not getting the right answer often enough. Although I'm also going to offer the idea that bias may also have value if it reflects our organizational values. This is less a bias than, I'll say, a limitation of machine systems. Machines treat all events as equal. Humans recognize the importance of some events and can sometimes rise to the occasion. If you're familiar with American baseball, I was 13 years old in 1971, and I was at Forbes Field watching the baseball team, the professional baseball team, the Pittsburgh Pirates, on a World Series run, and they did win the World Series that year. It's the bottom of the ninth, and the Pirates are losing by 1 run. They have one person on base, and a player by the name of Roberto Clemente comes to the plate. He was a fine hitter for average, and he's I'll say in the Baseball Hall of Fame. He was a fine hitter for average, but he was not at all a home run hitter. However, something within humans can recognize the importance of some events and sometimes can rise to the occasion. So in the bottom of the 9th inning, he hit a 2-run home, what we call a walk-off home run, which meant he hit the home run, and as soon as he crossed the plate, the game was over. The Pittsburgh Pirates won, and they did win the World Series that year. There's no mechanism in code to be able to do this sort of thing. We could have data and algorithms to recognize the importance of a specific event, but software cannot improve its answer. It cannot make an extra effort, so to speak. And as I pointed out, this is less a bias than an inherent weakness in our software systems. And this is why I think that the human in the loop is a very important part of any analytic and machine learning system that we have. Disasters often happen because software behaves in unexpected ways, and human oversight may well be necessary. The problem is that machines respond too quickly. There may not necessarily be time enough for human oversight. Where testing fits in, our data has to be accurate. We need to be proactive in testing. We need to anticipate bias, wrong answers, and something that we don't quite understand. But most of all, we need to ensure that the data that we use to train our data is well representative of the problem domain. We need a lot of scenarios when we're testing. We need to make sure we're including edge cases. Try to think outside the box. What can happen in real life that may not happen in an artificial testing measurement? And try to create a model from our test results. How is our machine learning system behaving based on hundreds of responses that we've got in our tests? In other words, I understand how this works now. So in conclusion, I'm just going to say that data is central to all of our applications. It's increasingly important in analytics, decision-making, and in particular, machine learning. Big data is now the norm. We're collecting terabytes of data almost daily. I remember when I worked for Dynatrace, we were literally collecting terabytes of data a day. We would store as much as anybody as our customers wanted, but we were literally collecting for all of our customers combined terabytes a day. And that data is managed by a DataOps process. But the data can't make our decisions for us. Let's put it in its proper role and say it's a decision support system. And the burden is on us. How can we respond? How can we make a decision when the required response time may well be in seconds? So if you remember this scene from the movie Indiana Jones and the Last Crusade, where the Templar Knight says to Indiana Jones in the cave, choosing the right goblet as the Holy Grail, you must choose, but choose wisely. Thank you.